I gave you my heart.
Hello, hello, and welcome to the third video of PySmash, the YouTube channel for Python tricks, tips, and tutorials. So, without wasting any further time,
let us begin.
So today we are gonna learn about the Imbalanced Learn library. So, what does this Imbalanced Learn library actually do? Imbalanced Learn is a Python package offering a number of resampling techniques commonly used in datasets showing strong between-class imbalance. So when we have datasets which have imbalance, then we can use this Imbalanced Learn library, which provides several functions by which we can actually address the imbalance in the data. As you can see, there are several options of oversampling, undersampling, and oversampling followed by undersampling processes, as well as some ensemble classifier which are specially modified for handling imbalance in the dataset. So whichever process we need, accordingly we can use that process by calling in that function from the Imbalanced Learn library. So we can now work with Anderson and Smooth on a Colab notebook. So let's go ahead.
So here we are in our humble Google Colab. This is where we will learn about Imbalanced Learn, and to run this Imbalanced Learn library in your Google Colab, you need to first install this Imbalanced Learn with the help of pip install Imbalanced Learn. So let's run this code. I have previously installed this library, so this would show requirement already satisfied. Yeah, so that's what it's showing. And then we need to install Kaggle. So thing is that we are working on a dataset of credit card fraud, which is a very popular dataset available on Kaggle. So when the data is imbalanced, so for that I could have downloaded the data from the Kaggle website and then have to re-upload the data in Colab. But if we install the Kaggle API in our Colab environment, we can directly download the data in the Colab environment and skip a step. So for that I have installed Kaggle, and there are a few more steps that needs to be taken care of, and that would help to not download the full dataset in your machine. So let's run this Kaggle, and also this is been pre-installed, so requirement is already satisfied. And then in Kaggle website we can get a JSON file of that API, which is being given in the profile section of your Kaggle. So you need to download that kaggle.json file and you need to upload it here. So this JSON file can be uploaded from this code. I upload it with the help of browse. So that uploads our Kaggle JSON, and then we need to make some additional codes. This is nothing much of complex code. This is actually making a directory of Kaggle and putting that Kaggle JSON inside it. I'm deleting the Kaggle JSON file which has been already present. So just to avoid any confusion, I'm clearing out this JSON file. Okay, so there is another Kaggle JSON, so I'm deleting that too. Okay, so that would do the trick. With the help of Kaggle datasets download, let's download the credit card fraud dataset. Okay, let's run this previous one. Okay, that's done. And let's download this dataset of credit card fraud. Okay, so it's skipping because the zip file is already being downloaded before. So one thing one needs to take note is that it downloads the data in the form of a zip file, so you need to unzip it to use the data. So just unzip with unzip code, unzip credit card fraud.zip. Let's run this. So it's asking me that if I need to replace the already present CSV file, so I'm giving it a yes. So the credit card.csv file is present and now all the files are here. So let's go on with our code. We need to import some additional libraries of pandas and numpy to read the data and some additional mathematical works. So let's read the data with read CSV. Okay, so it's read. Now let's check what the data has. So you can see that there are several columns with time and V1, V2 up to V28. So these are various attributes with last of amount and class. So this class variable is what is the point of importance. This is our target variable. This class has fraud and not fraud label, and that we need to predict with the help of a classifier. So basically that's the task of this credit card fraud detection. But we all know that this data set has imbalanced data because, as you can see, class has more number of zeros than ones. There are less fraud than good customers. So the number of people who are being found fraud would be very less, and making a classifier with that data, it would be heavily dependent on the good customers and not the fraud. So in order to do that, we need to balance that data set. So let's check if this has any missing data. No. So it has got, every attribute has got equal data, so no missing data is present, which is quite good for a data set. It has got 284,807 data points, each and every one of them. Okay. So let's describe this data. Let's go a bit deeper. As you can see, count is almost same. Mean, median, max is also not much of a difference, but yeah, different in various attributes. So those are not my point of concern. My concern was the target variable, which was the class, and it was imbalanced. So for that, I put the target variable in Y and the rest of the attributes in X. So I write df.drop class axis 1. So this would select everything except the class and Y as class. Then I use mode. This is one of the sampling techniques that helps in overcoming imbalance. So with the help of this Imbalanced, which I have installed on my first line of code, so with the help of that I import mode. So let's run this. Okay, now we'll fit it with the smooth balancing, and now you can see that the number of ones and zeros are equal. Both are 284,315. So it has very well balanced the data, and thus now we can make a classifier which would not be biased towards the majority class. So this is what smooth does. Next we would do the generic trend test split, and we split the data, and then we would use the decision tree classifier to build a classifier that would be able to detect a fraud from a non-fraud customer. So this would take some time to run. So let's fast forward it a bit. Okay, so now it has run. So let's see how the classifier did its job. So let's see how the confusion matrix looks like. As you can see, it has built a very good confusion matrix, and if you understand confusion matrix, you can see the number of the true positives and the true negatives are quite high, whereas the false positive and false negatives are quite low, which is actually quite good, and this would actually give a very high accuracy score, which is always a need for a good model to work. So quite good actually. So 109 and 48 is the misclassified ones, and the correctly classified are 56,615 and 56,954. So okay, now let's move on to Addison, which is another sampling technique. So nothing much to change, we just change the smooth with Addison and everything would work out just fine. There's no change in the process or the code, just a change of word of Addison, and everything should work out fine. So this would take some time, so I'm fast forwarding the video a bit. So this is it. So let's run the next part. Let's see how much balancing it has done. So as you can see, from smooth it is a bit different, as the number of zeros and ones are not equally divided. They are quite close, I would say, 298 and 315, but they are not equally divided. So I don't know how this would fare in the confusion matrix and how good classifier it would make, but this is what it is. So just run the model with splitting the data, and the same way importing decision tree, and let's see how the confusion matrix looks. Okay, so this is the confusion matrix of Addison. As you can see, the false positives and false negatives have lowered more. I can see it has, let's see, what was there, 109 and 48, and this has 98 and 38. So actually this is quite much of an improvement. This would surely give a higher accuracy than the previous one. So you can clearly see how a bit of balancing of data helps in making good classifiers. This confusion matrix proves my point, and so that's much about it. We can have used imbalanced learning to produce Addison and smooth, though there are various other sampling techniques which you can try out. I have tried this too, and I believe others would also help quite a lot in imbalanced datasets. So it's very easy. Basically, first we need to import this imbalance learn, then we need to import this data, then we need to import the smooth, split the data with the smooth, fit the data, then import the classifier, put the classifier in the data, and that's about it. So yeah, so this is more of how Addison and Smart was being used using the imbalance learn library, and I believe that this would help you in the long run while dealing with imbalanced datasets. So if you believe that this video has helped you in any way, smash that like button, share this video with your friends, subscribe to my channel, do follow my blog, and see you on the next one.
Wait to give you my heart.